Well, hey guys, Sunday night here. Mr. Roden's doing his asynchronous lesson plan for you guys tomorrow. So it'll be Monday, obviously, when you guys see this. And I just want to say hello. Hope everyone had a great weekend, long weekend. It was absolutely fantastic talking to you guys and talking to your parents and you guys, some of you. And it was really appreciated, your parents and all the support you guys have been given. Um, your parents been given to me as a teacher and to you guys. So um, be sure to thank your parents again for everything they've been doing. I really enjoy talking with them. All right. So our learning target today is I can perform sequences of transformations on the coordinate plane. Our agenda today is good things. Then we'll look at the homework bucket. I don't know if we'll look at the homework bucket. I'll just talk about it really quick, and then we'll do our lesson for today. Okay, sound good? All right. So my good thing for today is it's kind of like anti-daylight savings. I like spring forward's okay when it's daylight savings, but I really like it when we go backwards because I like to get up early and I like to have light in the morning. I'm an early riser, and I don't mind if it's dark at night. I don't care really. I'm usually in bed early, so I like having a little bit more sleep. Just seems like I got more of a day today. So I really enjoyed today because we kind of went backwards. Um, so that's my good thing. I wonder what your good thing is. We'll see. All right. So homework bucket. So hopefully you've gotten all that Delta math done. I'll put it in the computer tomorrow when I'm at Jenkins. When you guys aren't around, I'll put it in. And I do have, I know that some of you guys sent me some emails. I'll respond to those emails and questions you had. And also, so a couple of things that we will be having a quiz over transformations next this coming Thursday. I want to have a quiz over transformations, so get ready for that. We'll talk a little bit about that more tomorrow. And also, I'll have another homework assignment for you guys tomorrow. Also, some Delta math, probably Delta math, I think, to get you ready for the test. It's not a quiz; it's a test, a big test coming up on Thursday over transformations. So we'll talk about that tomorrow. Okay. So let's go ahead and get started on lesson 2.4. And 2.4 is sequences of transformations. Okay. So here's what I want you to do. I want you to pause the video right now, and I want you to write sequences of transformations. And then I want you to write this little mini paragraph here. And I'll read it to you, and then just pause me, and then you write it down. But let me just read it to you because you might be able to write it down when I read it to you. Okay, so here we go. A transformation is a function that takes points on the plane and maps them onto other points on the plane. Transformations can be applied one after another in a sequence where the image of the first transformation is the pre-image for the next transformation. Okay, so go ahead and pause the video and write that down. Hey, welcome back. So one thing I want to emphasize here, didn't mean to do that. Why did it do that? One thing I want to emphasize here is this part right here. Transformations can be applied one after another in a sequence of images of the first transformation as the pre-image for the next transformation. Okay? So, what I want to do here is, so basically what's happening is this. Let's say you have a pre-image P, okay? And you do a transformation on it, okay? So let's say we'll just some transformation on it. Transformation. So when you do a transformation on it, whatever that transformation was, you get P prime. Now, this is a pre-image, right? This is a pre-image. This now becomes an image. But when we do another transformation on it, this is now it's an image of this original one, and we'll call it P prime, but it's also a pre-image for the next one. And when we keep going, we like to put double prime, and you could go triple prime if you just whatever the transformation is. So in this case, we could go from the pre-image to the image to the next pre-image image to the next pre-image image. So, and the way you know how many times you've done a transformation to the original pre-image is the number of prime signal symbols you have. So 1, 2, 3 transformations, and we'll talk more about that in this lesson today. Okay, awesome. All right, so let's go ahead and do an example here. Okay, so first of all, we have reflect L across to reflect across L, then 90-degree rotation at point P. Okay, so the first thing that I like to do is I like to say if I'm ever going to be rotating, I always want to rotate about the origin. And notice I don't even have a coordinate plane here. All I have is just, and I have some writing on here that probably doesn't need to be here. I have some writing on here. So what I'm going to do is I'm going to make a coordinate plane, and I'm going to make P the origin of my coordinate plane. Okay? And so that's going to make my life a lot easier here. So first of all, let's go ahead and reflect across L. Now that's a piece of cake, right? So it's just one across here, one across here. So this is going to be my B prime. And then this is going to be one across here. So this is going to be my C prime. And then my A prime is going to be out, let's see here, 1, 2, 3. So 1, 2, 3. So 1, 2, 3. So A prime is going to be out here. And so it's going to look something like this. And that's A prime. Okay, now the next thing we're going to do is we're going to do a rotation around point P. Now, if I look at this, 90 degree, and remember, it's always counterclockwise. So what is the 90-degree counterclockwise rotation rule? It's X comma Y. What we do is we swap X and Y. So we get Y comma X, and we just change the sign on the new X there. Okay. So what I'm going to do is I'm actually going to create a coordinate plane out of this because I like using those numbers. So when I do that, it looks like that C is going to be, well, let me just do an alphabetical order here. So A is going to be at the point 1, 2, 3, 4, 5, 1. So A is going to be 5, 1. B, my phone is ringing off the hook tonight. B is going to be at 1, 2, 3, 1, 2, 3, 4. So we'll say A prime is 5, comma 1. B prime, I forgot to count. So 1, 2, 3, 1, 2, 3, 4. So B prime is going to be at 3, comma 4. And then C prime is going to be at 1, 2, 3, 1. So it's going to be at 3, comma 1. And I'm just going to apply the 90 degree rule here. So I'm just going to swap it and put a negative. So that's going to be negative 1, comma 5. Excuse me. And this one is going to be negative 4, comma 3. And this one is going to be at negative 1, comma 3. Okay? And so now I'm just going to graph that, and I'll go ahead and graph that in green. I'm going to turn my phone off because it is just blown up right now. All right. So let me go ahead and graph these. So we're going to have what? Negative 1, 5. So from here's the origin that I made. We go left 1 of 5. 1, 1, 2, 3, 4, 5. So this is going to be our A double prime because it's the second transformation we've used. This is the new pre-image, and this is going to be our new image. And then so we have negative 4, 3. So 1, 2, 3, 4, 1, 2, 3. So it's going to be right here. This is going to be B double prime. And then the next one is C prime is so what are we're at negative 1, 3. So left 1, 1, 2, 3. So this is going to be C double prime. And so it's going to look something like this. And if I did it right, I'll still get, because this is a rotation and a reflection. That's messy, sorry. A rotation and a reflection is a rigid transformation, which means that I'm going to get congruent or the same shape, just kind of turned or whatever. Okay, so it looks like, besides my poor drawing here, it looks like it will be turned 90 degrees counterclockwise. And I'm done. Cool. All right, so let's go down. All right, so your job is to copy this down. I'm going to make this a little bigger because I think it could help to make this a little bigger here. Okay, and what I want you to do now is I want you to go ahead, for example, 2, and I want you to translate it along V, then 180 degree rotation around P, then translate it along U. And I will tell you what you want to do on this one is you want to go ahead and you want to definitely want to put P at the origin. So you want to go ahead and put your y-axis right there and put your x-axis right here. All right, so copy it down and see if you can't do it. And I'll pause the video here, and then I'm gonna do the whole thing, and then I'll explain what I did here. So I'm actually gonna truly pause my video here. Go here. Okay, so let me explain what I've done so far. So hopefully you've gotten here so far. First thing we did is we did a translation along vector v. So vector v just rises 1 and runs 2. So from the original pre-image, each point I just rows 1, run 2, rows 1, run 2, rows 1, run 2. So this green one here is my image of the original black pre-image here. Now, and then I just copy down the points for E prime, F prime, G prime, negative 1, 3, 1, 1, and negative 2, 2. And then I applied the 180 rule. And if you remember, our 180 rule was just switch signs. So we just swap the signs here. We don't swap the X and Y. We just change the signs. So we went from negative 1 to 3 to 1 to negative 3, 1 to 1, negative 1, negative 1, negative 2 to 2 makes us 2, negative 2. Just switching the signs. And now that gives us this blue triangle right here. That's the double primes. Okay, so but remember what we're doing. We're doing 1, 2. Now we have to do our third, and I'll do that right here. I think that's pretty simple. And U is just what we're going to do is just we're not going up or down any. So U is just going to be a translation 1, 2, 3 to the left. So a translation of 3 to the left. I'll do this one in yellow. So 1, 2, 3. So there's my F triple prime. 1, 2, 3. This is my E triple prime. 1, 2, 3. This is my G triple prime. And then it's going to look something like this. And I'm done. All right, cool. Hopefully you got that. Ask questions tomorrow if you have any questions. But definitely a rigid transformation. Those triangles are all pretty much the same. They're just turned around and all the same size. Okay, so what I want you to do on number 3, I want you to go ahead and give this one a try. Example number 3. And it says, okay, so you want to translate it along this vector right here, and then you want to reflect it across the y-axis, and then you want to reflect it across the x-axis. So go ahead and do that right now. I'll pause the video, and then make sure you're pausing it, though. Don't just come to the answer. So pause the video now and see if you can do this, because you're going to need to do it on the test, and then I'll throw the answer up here in a minute. Okay, so let me go ahead and I'll pause also. Okay, so I think it might actually, so I took this vector right here and I drew it out here. If we call this vector V right here, This is vector v, and all vector v is, and remember, you can make vector v go anywhere you want as long as, the initial point can go anywhere you want. So this one is going to go, I don't think this is good. Never mind. I will come back to you here in a second. All right, I'm too lazy to edit that out, so I just went and changed it. So vector v goes left 2, up 3. So I'm going to take this triangle, and I just drew vector v down here. Again, remember, your vector your initial point can start anywhere you want. So I just put it down here because I don't think it would be in the way. I don't know if it's going to be in the way. I'll erase it later. All right, cool. So I think it is going to be in the way, but I'll erase it later. So now we want to reflect this. We took this whole triangle here, this pre-image, LMN, and translated it 2 to the left and 3 up. Okay, that looks better. Now we want to go ahead and reflect it across the y-axis. So when we do that, reflections across the y-axis are pretty simple. You just count how many spots away from the y-axis it is and just keep it at that same height. So here you're 1, 2, 3. So you go 1, 2, 3 here. So I'm going to change the color here to red. And so 1, 2, 3. So that's going to be n prime. And then m prime is going to be right here. And that's double prime, right? Because this is the second one. And then I think L double prime is going to be up here. So it's going to look something like this. And it's just the same. If y-axis is our flipped line, we just flipped it over to this other side. Now, I'm going to get rid of this vector down here because it's going to get in the way. All right, so now we want to go ahead and reflect it across the x-axis. Okay, so when we do that, we flip move this down just a tad here. So L triple prime is going to be right here. And there's a couple ways to do it. You could do this so, and then, M is going to be at 6, right 6, up 5. So we can go right 6, down 5 for M triple prime. And then N could be right here. 1, 2, 3. And then something like this. Not the best drawing, but it gets the point across. And so this is what you should have after this sequence of transformations. So hopefully you have this. Cool. All right, let's do the next one. All right, so the next one I'm going to do, and then I'm going to offer you a little bonus on this next one. Okay, so let's do this one really quick. First of all, this is a translation. Okay, and all this is saying is there's a lot of different ways to say translation. Here we're going to go left 1, down 1. So we're going to go left 1, down 1. That'll be my A prime. We're going to go left 1, down 1. This is going to be my C prime. We're going to go left 1, down 1. And this is going to be my B prime right here. So again, definitely a rigid transformation because it, all you do is translate it to the left. Left 1, down 1. X is left, right, Y is up and down. Okay, this one is going to be a non-rigid transformation, and you'll see why it's going to be non-rigid. So the first thing I should probably do is write out the coordinates. So the coordinates of B prime are 1, 4. The coordinates of, let me do A prime up here. Coordinates of A prime are 2, 1. And the coordinates of C prime, so this is, no, that's, sorry, my bad. A prime is going to be 1, 1, my bad. B prime is going to be 1, 4, and C prime is going to be 2, 1. Okay, now What we're going to do here is this is this non-rigid one. I'll make it in green. We're going to multiply the first coordinate by 3 and keep the second one the same. So A double prime is going to be 3, 1. B double prime is going to be at 3, 4. And C double prime is going to be at 6, 4. And you'll see that this is going to change drastically. So 3, 1. So over 3, up 1. And this is going to be my A double prime. Then the next one's 3, 4. So right 3, up 4. And this is going to be my B double prime. And then 6, 4. So right 6, up 4. So it's going to be something like this. And there is my C double prime. So it's going to look something like this. And you're going to see, guys, that this is no longer a This is no longer a rigid transformation. This is a non-rigid transformation when you multiply by 3. Hopefully I did my numbers right here. If not, we'll talk about it tomorrow. Hopefully that looks good. It's kind of getting late here at night, so if I make a little math mistake, let me know in the morning or on Tuesday. Okay, so now the next thing I want to do is I want to do this. Now, what is this? This is a 180 degree rotation, right? And how do I know that that's a 180 degree rotation? Well, because the signs got switched. So if it's a 180 degree rotation, then I only do them in red. So that means it's going to be a triple prime. It's going to be -3, -1. B triple prime is going to be at -3, -4. And then C triple prime is going to be at -6, -4. So left 3 down 1 for A triple prime. So here's A triple prime, B triple prime, left 3 down 4. And then C triple prime, left 6 down 4. So it's going to look something like this. And it definitely will be a rigid transformation. This last one's going to be rigid. It just will be rigid. The green and the red are going to be congruent to each other, and the blue and the black are going to be congruent to each other. All right, so I want you to do this one. If you want to do this, I'm going to offer you an extra credit opportunity here. So right here, here's your sequence of transformations right here. Okay. And I want you just on a piece of graph paper, I want you to go ahead and graph the pre-image, complete the series, the sequence of transformations, write them out, the points and things like I did, like on this one. It'll look just like this one. Notice what I did. I graphed it, but I also changed everything and wrote them out. And then if you can email me a picture of this by, let's say, I'll take it by 11:59 tonight. So 11:59 on Monday night. I'll give you some extra credit. I'll give you 5 points extra credit for this, okay? So if you want some extra credit, here's an opportunity right here. Email me a picture. If it's all good and it looks good, I'll work this out. And if I agree with your sequence of transformations on this one, I will give you 5 points extra credit. But you have to email it to me before 11:59 tonight, and I'll give you 5 points extra credit. Okay? There's an opportunity for some extra credit if you want to boost your grade up a little bit. All right? Okay, so let's do one more, and then we'll call it good. All right, so the last one here is translate 4, then rotate 90 degrees counterclockwise around A. So this is interesting, and then we'll reflect over the y-axis. Okay? All right, so let's take a look at this one together. So first of all, what I'm going to do is I'm just going to go ahead and do this vector. So this vector is going to be 4, 4. So I'm just going to take each one of these points, and I'm going to go 4 to the right and 4 up. Okay, so let's do that right now. So A, 1, 2, 3, 4. 1, 2, 3, 4. So A prime, I think, is going to be right there. B, 1, 2, 3, 4. 1, 2, 3, 4. So B is going to be right here, B prime. C, 1, 2, 3, 4. 1, 2, 3, 4. So here is C prime. Oh, sorry. It's going to look something like that. And that's just a good old-fashioned rigid transformation, which is just a translation. Looks good, right? Okay, now here comes the fun part. We're going to rotate counterclockwise about A. Now remember, where do we always rotate about? What's the point we always want to rotate about? Yeah, the point we always rotate is the origin. And notice A is not at the origin. So what I'm going to do is I'm going to recreate this graph temporarily, and I'm going to make A the origin just for now. And I'm just going to pretend like A is at the origin. And then I'm going to use my rules to rotate 190 degrees. 190 degrees, 90 degrees. Okay. Okay, so let's pretend now A is at the origin. So forget about all these numbers for a second. These numbers don't matter right now. We'll bring them back. So I don't know, it might be hard for you to just scratch them out. But just pretend they're not there for now. And remember what our new numbers are really. This is our new origin, okay? And so what we're going to do is I'm going to go and I'm going to list these numbers out using my new origin of A, okay? And I'll do it in green. So first of all, let me list it out. So A prime, using my new origin, is going to be at 1, 2, 3, 4. 1, 2, 3, 4. So A prime is going to be at 4, 4. B prime is going to be at 1, 2, 1, 2, 3, 4, 5, 6. So 2, 6. And C prime is going to be at 1, 2, 3, 4. Excuse me, let me do that again. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So C prime is going to be at 3, 7. Now remember, we want to do a 90-degree rotation. So what is a 90-degree rotation? You take XY. You do this one in green because that's what the color I'm going to be doing it in. You take XY, and then you just swap the X and the Y. So the Y and the X get swapped and change the sign on the new X value. Okay, so when we do that, a 90-degree rotation, that's going to give me negative 4, 4. That's going to give me negative 6, 2. And it's going to give me negative 7, 3. Okay, so let me go ahead and do that. Now I'm going to go back to the A is my new origin because I made it that way. And so I'm going to go left 4, up 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is going to be and remember, this is going to be A double prime. This is going to be B double prime. Left 6, up 2. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2. This is going to be my B double prime. And then C double prime is going to be left 7, up 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So that's going to be my C double prime. Okay? So it's going to look something, let me get B double prime is kind of in the way here. A double prime, you're kind of in the way too. it's going to look something like this. Okay? So we got turned around point A. Now, we're done with that. So now we want to reflect it over the y-axis. So what I can do now is I can get rid of all this. I don't need this anymore because I only did that because I was going to do it reflection. So I'm going to get rid of all that. Okay, now I'm going to reflect it over the y-axis. Well, let me do it in yellow. So y-axis, it looks like it's 1, 2, 3, 4, 5. So we're going to go over to 5. So same level up to 5. And so that's my A triple prime. B is going to be over at, it's going to be down at 4, 7. So we're going to be at 4, 7 over here. 4, 7. Oh, by the way, 8, I think it's at 5. So here's 5 right here. I think this is going to be my A triple prime right here. And then B is going to be at 4, 7. So 4, 7 right here. There's going to be my B triple prime. And then C triple prime is going to be at 8, 5, 8, 5. So 8 up to 5. Let's be right here. B triple prime, you're in the way. You're in the way. B triple prime, 1, 2, 3. And then C triple prime's here. So it's going to look something like this. And again, all rigid transformations. That doesn't look, let's see here. Yeah, I just think I need to just clean that up a little bit. It's like right here. How's that look? Did I do it right? See, so that's going to be at 5. Oh, A's got to be at 5, 6. My bad. Why is this so hard for me? This is the easiest part. So A triple prime is going to be at 5, 6. So A triple prime's here. All right. B triple prime is going to be at 7, 4. 7, 4. So B triple prime is going to be right here. And C triple prime is going to be at 8, 5. 8, 5 right here. Something this. How's this look? A little better. Something like that. All right. So that should work. Not the best drawing. And we're done. Okay, guys. So this is what I need you guys to do. Remember the extra credit problem. And remember we have a test coming up on Thursday. We'll talk about more of that tomorrow when we meet in the live session. Okay, guys. I will see you later. Have a wonderful day. And see you later. Bye.